Hopefully everybody can see that slide, road regression tools and workflows. Again, my name is Scott Urbis, and I'm the manager of our civil training content. So me and my team basically handle creating a lot of the open roads training courses that are delivered by our civil consulting team. So we also create a lot of the courses that are available on the Bentley learning platform as well. Okay, so let's get started with road regression tools and workflow and flows. So full disclosure here, I have presented this earlier this year in a coffee corner, made some updates to it. So some things are a little bit different, but it's essentially the same presentation. So first, let's take a look at the agenda. I want to focus on the horizontal regression tools inside of Open Roads Designer. So back in 2022, the 10.12 release, we took the regression tools from OpenRail, just the horizontal regression tools from OpenRail, and we added them to Open Roads Designer. So I'm going to focus on every one of these tools. We're going to dig real deep into these so you can get a better understanding of how they work. So we're going to spend a lot of time just going over these horizontal regression tools, regression line from points, regression line from line, curvature diagram, single horizontal regression, quick regression, slew reports, all those tools. I'm going to basically touch on a lot of these, almost every single one of these. And then after I cover those, I'm going to get into some of the legacy best fit type of tools that we have for horizontal and vertical, for creating best fit horizontal and vertical geometries. So that's kind of what we're going to cover today. Hopefully I can do this all within an hour. I think I can. I only have about 25 or 26 slides here to get through, so shouldn't take up the whole time, but we'll see. Continue on here. So before I get started, I just want to highlight one of our training courses. Almost everything that I'm presenting today is covered in the step-by-step training course called Road Regression and Redesign. This course has been around for a few years now. Just kind of goes through the same tools that I'm going to be showing today. Shows some extra stuff too, but if you're interested in going through that class, it is on the LEARNserver. I'll give you guys a link to this course at the end, but this is the name of it. If you just want to do a search on learning.bentley.com, our new learning system, you should be able to find it out there. It's got videos and data sets and whatnot. So everything I'm covering today is pretty much inside of this course. So let's first just define what regression is. Not everybody's familiar with this term, regression. So regression is a best fit process where the new alignment geometry is defined to fit as closely as possible to a collection of known coordinate points or geometry surveyed along the existing road, right? So these regression tools that we have, they help us define an alignment along an existing piece of geometry or through some existing points, right? Typically, this is going to be used when you're trying to define some type of best fit alignment through along a center line, most likely, right? So here's the tools that we have. We have the regression line, curvature diagram. We have tools for creating the actual different geometric pieces. So I have all those highlighted here. We're going to go through those. And I have some notes down here at the bottom. Only the horizontal regression tools are available in Open Roads Designer. If you're an OpenRail Designer user, that one has a more robust set of regression tools. It has horizontal and vertical, as well as some advanced functionality. And that's only available in OpenRail Designer. So if you need something more than what I'm showing you today, then you might want to take a look at OpenRail Designer. And also take a look at the session on Thursday, what's new in OpenRail Designer, where they're going to be showing some of that other functionality. So for today, we're just going to be mainly focusing on open roads and looking at the regression from the roadway designer's point of view. If that makes sense, okay? All right, so let's continue on here. So just take a look at the general workflow when you want to use these tools. You know, maybe your project manager comes to you and says, hey, we need to create a best fit alignment for this particular roadway. We have some survey data, we have some points. We need you to create a best fit alignment, right? So this whole process starts with first having that data. You got to have some data, right? You need to have 2D points or a 2D line string. That's first and foremost. And then it's going to start with creating a horizontal regression line. It's going to match as closely as possible to that existing survey information. And then from there, you're going to take a look at the curvature diagram to try and figure out where the tangents and curved areas are of this information. And then you're going to go through and utilize some of our special tools, the single regression tool or the quick regression tool, to actually create the best fit regression geometry elements. And once you do that, you're going to typically go through and report and review the slews, which are the offsets from the original data to the new geometry or the best fit geometry. And then if you need to create some best fit vertical, we have some other legacy tools in OpenRoads where we can do that. I'll show that a little bit later. Then you could go and do some best fit workflows as well. So we're going to focus on these 4 for now, and I'll show you number 5 later on towards the end of the presentation. So first, let's talk about the process here. So the process you need to do is, you got to have either a 2D line string. Everything I'm doing is 2D. Okay, you have to be in a 2D file first. You have to have either a 2D line string or 2D geometry points. Okay, it's very important. 2D geometry points. This does not work on survey points. So if you have survey points, you're going to have to export those and import them as 2D geometry points. Okay. So this stuff is all hooked up to the civil geometry engine. So that's why you have to have 2D geometry points. Okay, so our first step here would be to either create a regression line from points, if you have points, or a regression line from line. A line could be a 2D line string, right? So it could represent some existing center line that the surveyor has surveyed, anything along those lines. Okay, so this is the tool here. Let's take a quick look at an example of using regression line from points. Do a little quick video here. Okay, so here's my survey points that I've imported. You can see those over here in the OpenRoads model. The points have been imported here. Okay, these are geometry points that I exported from my survey data. All those are stored in my OpenRoads model explorer here. Go to my geometry tab, and now what we want to do is create the regression line so it can regress this data and come up with a regression line and some regression points for us to use for our regression analysis. We're going to go ahead and select regression points. Now you need to select all the points first. So I'm just going to use the element selector to select all my points in my file. We'll activate the tool here, say regression from points. Now we need to enter some parameters here. Okay, so these parameters will vary based on the data that you have. I'll talk more detail about these parameters next few slides. So we're going to set those parameters. We're going to set our feature definition. We're going to data point to accept those points. Those will be the points that will be used for our regression analysis. And then at this point, it's going to prompt us to locate our start point, our first point for our start point, and it's going to also prompt us for a second point so we can define the direction. So it knows which direction to look at these points as it's going through these various regression parameters. Once you step through that, it recreates the regression line. So you can see over here in the OpenRoads model, we have a regression line now. And we also have some regression points that are associated to that as well. Okay, so that's the first step in the process, is just creating that regression line from those points, utilizing those parameters that I defined there. Okay, now, if you don't have points and you just have some 2D graphics, 2D line string of some sort, we can do that as well. So this example here would be utilizing regression line from line. So this would be a case where we have an existing 2D line string that maybe represents our center line of our existing road. We want to create a regression line along that. We're going to go up and select regression line from line. And much like the regression line from points tool, it has a lot of the same parameters. So I'm going to go ahead and click on this. That should bring up the tool. You'll notice it has the same parameters: minimum distance tolerance, maximum distance tolerance, minimum deviation, max deviation. All the same settings there. You only have a couple different differences down below, where you have a points feature definition and then a regression line feature definition. So I'm just going to set those. Right. So let's go ahead and set the feature definitions, the names. We're going to go ahead and locate our existing 2D survey line string there for our road. And we'll just step through the parameters. Then what it's going to do is it's going to create the regression line as well as the regression points. It goes through and does a little bit of calculation there. Create some regression points for us along that line. You can see all those points over here in the OpenRoads model. And up here you can review the regression line that's been created. Okay? So that's the process if you have something that's a 2D line string and you need to do a best fit through a 2D line string. Okay? Just how the tool works. So let's continue on here. So now once you have that data, let's talk a little bit about these settings, because you have some very specific parameters here that you want to set based on the type of data that you have. So let's take a look at these design parameters, talk a little bit about these in some detail. So this first one you see here, the minimum distance tolerance, okay, that defines the minimum distance in the search for the next point during the process of ordering the regression points, okay? If you look at my little diagram here, there's some circles drawn here. There's some regression points that are shown here. I got some the max deviation called out here. And this kind of relates to the regression points that I'm showing and these parameters that are shown in the regression dialog box here. Okay, so the minimum distance tolerance, it's represented by this smaller circle here. So my current regression point is 1, and my previous regression point was this one here. You can see that the minimum distance tolerance defines that particular distance from point 1 to whatever maybe the next collection of points are, and then the maximum distance tolerance is the maximum distance from that current point to where the next collection of points would be. Okay, so when we talk about the minimum distance, it just defines the distance in the search for the next point during the process of ordering the regression points, and the points must lie beyond the minimum distance tolerance from the current regression point, which is 1, to be considered as candidates for the next regression. Now the value you enter here should be less than your standard distance between consecutive survey points. Maximum distance tolerance, that's going to define a maximum distance in the search for the next point during the process of ordering the regression points. So if you refer to the circle here for at point 1, put in a maximum distance from there, it's going to get you out to here. So you can see any point that would fall in between the maximum distance and the minimum tolerance there, it would be points that would be included. So points that must lie closer to the maximum distance must lie closer than the maximum distance tolerance for the current regression point to be considered as candidates for the next regression points. Okay? So kind of refer to this diagram. This diagram is straight from the Open Roads help file. So if you're interested in getting like really more details about this than what I put in my slides here, feel free to take a look at the Open Roads help, because that's where I got this image from. Okay? So starting from point 1, you set a minimum distance tolerance out to here, set a maximum distance tolerance out to here, set a maximum deviation. As long as those points fall within those parameters that you define here, then it will include those points for processing in the regression space. Okay, so maximum deviation, once again, this is just going to be measuring from a projected line from the current regression point and the previous one. So this just kind of specifies the direction. And the maximum deviation, again, just an offset measured from this projected line that you see here. And it just defines a zone inside which the points must lie to be considered as candidates to be the next regression element. And the whole purpose of it is to ensure the search for the next regression points is restricted to lie generally in the path of the previously ordered regression points. It kind of gives it direction. Then we have minimum deviation. Minimum deviation, this one's going to be more used when you have a lot of data and you need to kind of thin it out or not include a lot of it in there. So this is also going to specify an offset measured from the projected line through the current regression point in the previous one. It defines a zone in which side, but this zone is going to include points which will not be considered. Okay, so when you set the minimum deviation offset here, you want to set this for points where you want to throw out. You don't want to consider those in your regression if you have a lot of them. Okay, so this minimum deviation parameter, generally that's going to be used for removing like near collinear points that do not contribute to the analysis, or you want to just reduce the number of points in your regression analysis. It's especially useful if you have some LiDAR information or some data coming from reality models where you have an excessive number of points and you don't want to regress all that stuff. So just another way to kind of filter it out. So those are the parameters that exist inside of the toolbox here for create regression line from line and line from points. They function pretty much the same. And also when the regression points are created, there are some properties, so you can further make some adjustments if you need to. There's some options to adjust the weight of the point, some options to use the point, so actually use it in the regression. You have options to ignore the point if you don't want to use a set of points, or just want to throw a point out from the regression analysis, you can do that by saying ignore point. The option is to fix a point, or you can have an option to just flag it as an informational type of point. So that's all available in the properties after the points have been created. Okay, so just want to point that out. So let's continue on here. So once you have your regression line and you're comfortable with your regression points and you've reviewed that information, now we need to take a look at creating the actual best fit geometry. So one way to help us do that is to utilize the curvature diagrams. You'll notice inside the software there's a tool here called curvature diagram, and that's going to be helpful for representing the curvature along the path of these regression points. Okay, it's going to help you determine areas where there's going to be curves, areas where there's going to be tangents and spirals and things like that. So let's do a quick example of this curvature diagram here. So once again, I'm inside my file. I'm going to go up to the curvature diagram here. We'll select that. Now for this to work, you have to have a regression line already created. So in my case, I do. So I'm going to come over here and select my regression line. Then it's going to prompt me to open up a regression space or a regression model, similar to a profile model. So here we have the curvature diagram. Okay, so points that are closer to the 0x axis there are going to be in tangent section, and points that are farther away from the x-axis are typically going to represent a curve or a spiral. Okay, so it just helps you kind of further take a look at certain areas where you may want to be creating your best fit through some of these regression points. Okay, so what we'll do here is we'll just kind of analyze this information, take a look at it, and kind of figure out, okay, where are we going to have curves, where are we going to have spirals, things like that. And then you could kind of come in and add those elements as needed in very specific areas just by analyzing this data. Okay, so further expanding on that curvature diagram. So what you saw there, that horizontal axis, that just represents the stationing along the alignment. And then the vertical axis represents the deflection of each point relative to its neighboring points. And like I said, in the diagram, any points that you see that are closer to the horizontal axis have low deflection values, which means they are going to typically be on a tangent line. And the points that are farther away from the axis are going to represent curves. You see transitioning zones are probably going to be spirals or some kind of curve combinations. Okay. Now the sign of the vertical value that you see in the curvature diagram over here on the y-axis here, so the signs of positive values and negative values, so what we're referring to here. If it's a negative value, it's a left-hand curve, so that means it's below the axis. The positive value, it's a right-hand curve. Okay, so negative left-hand curve below the axis, positive right-hand curves above the axis. Okay, let's go back to that diagram again so you can see what I'm talking about. Down here, up here. All right, so let's continue on here. So once we've analyzed the curvature diagram to help us determine the geometric elements that we want to create, let's actually talk about the tools that create the best fit geometry or the regression geometry. Okay, because at the end of the day, talking about regression, it's basically just best fit geometry in its simplest terms, right? So we're going to take a look at single horizontal regression. So this single horizontal regression tool, basically it just creates a single horizontal geometry element that is best fit to that regression data. Okay, so we use the regression line from points, regression line from line. We use those tools. Now it's time to come in and actually create the civil geometry elements. Okay, and so this one here is more of a manual process. You determine which geometric elements you want to create, and it's only going to create lines or arcs. Okay, and it works in the plan view or the curvature diagram, so you can use either one. If you don't want to use the curvature diagram, fine, don't even look at it, just go grab the regression line in the plan view and you can specify the type of geometry you can create that way. Okay, so let's take a look at this example, single horizontal regression. Okay, so once again, we've already created our curvature diagram here. Like I said, you don't necessarily need the curvature diagram. I just wanted to show it and how it works. For using this tool, we can simply select the regression line in the plan view as well. So we've got two options there. Okay, so let's play this little clip here. So we'll go over to the single horizontal regression tool. Let's go ahead and select that. It's going to prompt us to select the regression or curvature line. So once again, I can select this in plan view, or I can select it from the curvature diagram. Doesn't matter, either one will work. It's going to give me the same results. Okay, so now at this point, what I'm going to do, notice in the toolbox here, I have the geometry set to automatic, so it's just going to determine if it needs to be a curve or a line. So you can also see visually in the plan view that, the areas where there's curves and the areas where there's tangents. So not a big deal there. So I'm just going to go ahead and set a start point and an end point. If you do want to force a curve or an arc, we can do that as well. So I'm just going to set my start point and my end point here. And we want to capture some of these points in the curvature diagram. These are going to be the points that are going to be used for my best fit. It's going to look at those regression points from the curvature diagram, and it's going to generate a piece of geometry in my 2D plan view in view number 1. Okay, so those points that show up in that boundary box there are going to be the points that it uses for the regression analysis. Okay, so now if we take a look at the plan view here, you can see we have a curve that's been created through those points. Okay, so that's our best fit piece of geometry, our regressed geometry, if you will. Then down over here, you can see we have a tangent section of our alignment. So if we want to create a best fit tangent or a regressed tangent through that area, we can simply utilize our regression space here, set our start and end zone there, and expand our boundary box, and it's going to include those points for the regression analysis, and it's going to create a tangent line through that particular area there. So when we zoom into the plan view up here, you're going to see now we have a tangent line piece of geometry that's best through there. And you can also see the slew values as well, which we'll talk about here shortly. Well, the slew values are going to be the offsets or the difference between the existing data and the proposed geometry, best fit geometry. Okay, so continuing on here. So once you have your best fit geometry, it's usually a good idea to run a report on that best fit geometry to determine how tight or accurate that data is to the geometry that was created and to the original data as well. So in this particular case, we want to talk about creating the regression report and reviewing the slews. And some people may not be familiar with this terminology of slew. What is a slew? I've heard this. What does that mean? It's basically just the offset of the regression points to the newly created geometry. Okay, it's just the difference. So here I have a picture of that report or a screenshot of that report here. You can see the slew there. It just basically it's kind of like the error between the existing versus the proposed. So obviously bigger slew values means there's greater error there. So a lot of times you're going to be looking, when you're looking at this report, you want to look for things that are smaller values because that's going to mean it's going to be a tighter fit and a greater accuracy, right? So as I have on my slide here, smaller offsets represent a tighter fit to the data and greater accuracy of the regressed geometry, and larger offsets indicate more error and less accuracy, right? Okay, so let's take a look at the slew report here. Pretty simple to use. Got my curve here that was created using the single horizontal regression tool. You can see the slew values there. So you can graphically see them on the screen. But if you need a more detailed report, we could go into the regression report and take a look at that in more detail. Okay, so I'm going to navigate over here to horizontal regression report. We'll locate our center line element there, or our arc element. We'll locate our regression line so it can compare those two together to determine what the slews are. And then here's our report there. So you can see all the different slew values. So you can kind of determine where the greater the slew values are to kind of maybe make some adjustments in those areas. So if you see really big slew values, it means it's not as tight of a fit. So you may want to either throw those points out or further make some adjustments if needed. Okay, so let's continue on here. So then our next tool for helping create best fit or horizontal geometric regression type of elements is the quick regression tool. So this one's a little different than the single horizontal regression. The single horizontal regression tool, like I mentioned, it just creates single individual elements based on the data that you have. This tool will actually do an initial best guess of all the elements. So it'll actually create multiple elements and it will create the alignment, okay? So sometimes just using this one right off the bat may give you the best answer depending on the data that you have, okay? So this tool, it only works on the plan view line, so you have to have the regression line in there. You don't need a curvature diagram at all. It's only going to work on the plan view in the regression space. And it's going to create regression lines. It's going to create arcs that fall less than or equal to the tolerance value that you set in the dialog box here. So depending on your data, you're going to have to play around with the tolerance value to get it to give you what you would need. If you need to include spirals, you do have an option to toggle on spirals. And the nice thing about this tool is it creates collinear and coincident elements. So this is super important. Make sure it maintains tangency and there's no angular differences between elements and things like that. So very useful tool. If you just need something, get something quick and you don't want to dig into the details of the other tool with the curvature diagram and placing multiple elements manually, this one can pretty much take care of it right off the bat for most situations. But it really depends on the data and what you're trying to do in your project and everything. So let's take a quick look at some of this in action here. So quick regression, again, we've already gone through, we've created our regression line, we have our regression points, we did all that earlier in the presentation. So here what we're going to do is we're just going to identify and select our regression line. We'll set our start and end station. So we want to regress this whole thing. We want to create some new regression geometry between the start and end points here. I'm going to use a tolerance of 0.75 and then go through and accept that. And then what happens there is it goes through, it creates my horizontal alignment for me, and it creates all those individual elements, taking into account the regression points and the regression line. Okay, so it's going to try and do its best to try and fit through that regression line or those regression points that were created. So it's very much a best fit type of alignment there in that situation. Okay. So I'm going to pause for a second just to take a quick look at the questions here. See, there's still quite a few out there, so we'll try to address those when I'm done here. So let's continue on. So again, just some of the settings in that quick regression tool. The tolerance, that just defines a tolerance for the original curve fitting. Horizontal lines and circular arcs are created with an offset less than or equal to that tolerance value. So again, you're gonna have to adjust that tolerance value based on what you're trying to do, based on your project requirements, things like that. There's also an option here to apply a dekinking radius, which pulling most of this information from the help file. So from the help file, it says this defines a radius that is used to insert a circular arc if possible between two adjacent linear elements. Okay, so if you need to just create curves and arcs, you may want to consider applying a dekinking radius. Can also include spirals, so don't forget about the little spiral checkbox there if you do need to include spirals. And also remember, when you do use the quick regression tool, as I mentioned in my previous slide over here, it does create collinear and coincident or elements, so everything is tangent. Okay, super important. So let's go through here. Let's get into some other things regarding best fit. So we talked a lot about regression. I kind of defined what regression was back in the first couple slides there. But generally, when you're talking to engineers or surveyors, they probably don't use that term regression when they're trying to create something that's like a best fit alignment, right? They will probably use the term best fit. So I wanted to get into some of our legacy tools that we have in the software that are actually called best fit. They're not called regression, but they do some type of regression techniques behind the scenes, under the hood, if you will. So the first one we're going to take a look at is the Defined by Best Fit tool. This one's been around for many, many years, dating back, I think, all the way to SS4, maybe even before that in the SS2 products. There was always some type of best fit tool, right? So I'm going to highlight a couple cool examples, things we can do with that tool from the horizontal aspect. So we'll do one example that shows a center line along the existing, creating a center line, existing center line along an existing 2D line string, and then we'll do another example where we're going to do a best fit center line between two existing edges of pavement. And then I'll show you how to do some vertical stuff, because remember, the regression tools from OpenRail, the vertical regression tools are not inside of OpenRoads. So we still need a way to be able to do some basic best fit on our vertical data if we need to. So we do have a couple options there. So I want to show that just so you guys are aware. So let's jump into this. So this first one, we're going to take a look at the horizontal best fit tool. It's called Define by Best Fit, and we're just going to have it make an alignment based along an existing piece of existing 2D line string from survey data. Okay, so let's take a look at this option. Some of you probably have seen this before. Like I said, this tool's been around for many, many years. Still inside of OpenRoads. It's been brought forward from SS3 and 4 and whatnot. So here's my existing center line string there, and what we want to do here is basically create a best fit alignment from that line string, just like we did with the regression tools. This is just slightly different workflow, just a different tool. Okay, so this tool can be found under the horizontal portion of the ribbon. Go under complex geometry, select Define by Best Fit. Toolbox will come up, and there's a couple modes that you can utilize here. So the mode that I'm going to use is Make Complex Element. We also have some options in the Best Fit Parameters portion of the dialog to create an envelope, as well as radius rounding and some other input fields. Okay, so I'm just going to set those as is. I'm going to have it round the radius to 100. Just leave the envelope set to 2. And then for the feature definition, we'll be using geom underbar baseline, and we're going to create a Highway 72 eastbound alignment. So at this point, it's going to ask us to locate our linear objects. We'll go and locate that existing center line of pavement there, and we're just going to step through the prompts. Okay, so now at this point, what it did is it went through and created that best fit alignment, very similar to how we use the quick regression tool. So you can see we indeed do have a best fit alignment there, but you can see it goes a little bit off track over here. It's not very accurate in some areas. So, this may be a case where you may want to make some adjustments to your curves there, or maybe you want to go back into the other regression tools and see if it does a better job of performing a best fit on the same data. Okay, so we have some options there for creating a best fit alignment. So I just wanted to show that utilizing the other tool. So let's do another example here. So we'll use the Define by Best Fit again, but we're going to change the mode this time to Complex by Edges. And this is going to be an example where we want to create a center line between two existing edges of pavement. Okay, probably a pretty common scenario out there in the real world. Right, so here's my project again. So this time what we're going to do is we're going to take a look at our existing inside edges of pavement here, and we want to try and have it split the difference and create a best fit center line between those edges. So I'm going to change my mode here to Complex by Edges. My best fit parameters, I'm just going to leave set as is. And then for my feature definition name here, we're just going to call it Highway 72 centerline. I'm also going to round off my radiuses so I get some nice even numbers for my radii. And then it's going to prompt us to locate the primary edge. So I'm going to select my first inside edge of pavement, my second edge of pavement, and I'm just going to go through the prompts here. And it's going to go through and create a best fit alignment based on that data, trying to split the difference and kind of center it up between those two edges. Pretty useful tool there when you have to do that kind of thing. Now, furthermore, if you want to make this and check it from a design standpoint, we can utilize our design standards here, apply a design standard to that best fit data, and you can see right away that what it came up with does not adhere to this particular design standard that I had set. So if we go down into our Civil Message Center here and we take a look at our warnings, you're going to see that the alignment there that it created, it's not ideal, but at least it kind of tells us, hey, you need to do some further manipulation to make it meet design standards, so we can go into some of our other tools and make adjustments if we need to. So go into table editor, geometry builder editor, some of those types of tools, and maybe make some adjustments so that it meets the proper design criteria. Okay, so I just wanted to show that option there. Looks like we still got some time here, so we're doing good on time. Looks like there's still some questions in the chat. We'll get to those in a little bit. So now let's talk about the next tool here. So I think we've pretty much exhausted all of our options as far as what we have for creating best fit type of alignments. We have the regression tools up on the regression part of the panel, and then we have the best fit tools. Okay, so but we've been ignoring vertical so far, right? And why did I ignore vertical? Well, we don't have the vertical regression tools from OpenRail in here, but we do have some other best fit type of tools for vertical applications. Okay, so if you do have to do some type of vertical best fit workflows in OpenRoads, that's perfectly fine, because we do have a couple good tools that will take care of that for you. So the first one I'm going to talk about here is kind of a hidden one, hidden gem, if you will. So here's my eastbound center line that we just created in that other video. I'm going to open up a profile model of that eastbound center line alignment here. So you can see there's my existing ground profile along that Highway 72 eastbound alignment. I want to show you real quickly how we can create a best fit vertical from this data utilizing a hidden gem, or a secret tool, as I like to call it. So let's go take a look at how we can do this. Of course, you can come in here and just start using regular civil geometry, but if we want to create something that's truly a best fit, I'm going to go over here to this Site tab. And underneath the Site tab, there's a little tool over here that's hidden down below that's called Best Fit Profile. So I'm going to go ahead and select that. This is going to perform a best fit type of analysis, kind of a regression analysis behind the scenes. And you can enter a minimum K value, minimum tangent length, a maximum slope, a minimum Z, and a maximum Z. So you give it some design parameters here. And once you have those design parameters set, it's pretty simple. You just come down into your profile model view, select your existing profile there, and just go through the prompts. And notice it's going through and it's analyzing that existing ground profile, and it's performing some type of regression analysis, sometimes some type of algorithm, right, to analyze that data based on the parameters that you set there. And it's trying to do a best fit to that existing ground profile. It's kind of the whole purpose of this tool. It's basically meant to try and give you a best fit to your existing ground. Okay, so when it does that, it does create a civil geometry alignment, vertical geometry alignment there. Now, it doesn't create it with a feature definition at first, so I'm going to have to come over here and assign a feature definition to it so I can get my proper colors and things like that. So I'm just going to set the feature definition on there. And let's give it a more proper name as well. So we'll give it a name, give it a feature definition. And so we'll just go select that just to give it some, stylize it a little bit. So now there's our vertical. You can see the vertical curves and the tangents and whatnot. Okay, so now at this point, it might be a good idea to check those design standards again, like I did on the other horizontal geometry, right? So again, all this is regular civil geometry. So if you do need to make changes, you can come in with any of the other tools to do that. All right, so I'm going to come over here and let's take a look at the design standards again. I'm going to activate those. And I want to apply those design standards to this particular vertical alignment. So we'll just navigate through our design standards here. We'll use 65 miles an hour. Make sure you're using the proper stopping sight distance library there. Let's activate that, and then we want to assign it and set it as the design standard for this particular vertical, so we can check it against our design standards. Okay. So we've applied that design standard. Now at this particular point, we can either go into the Civil Message Center, see if it gives us any warnings, or you can go up to some of the other tools like the table editor, for example. So let's use a table editor this time, and you can see where these areas where it shows red, it's not meeting design standard. You can clearly see that. It gives you a heads up in the table editor that you may need to make some adjustments to some of your values. Okay. All right. So yeah, so that best fit profile tool came from the site tab over here inside of OpenRoads. It's just kind of hidden there. Not sure if a lot of people know about that. I know we've showed it a few times in different presentations over the years, but just something that was kind of hidden there, and works pretty nicely for an application like this for when you're trying to create a best fit along an existing profile. All right, so finally, let's get into the last tool of the day here, the define profile by best fit. Once again, we're going to be trying to create a proposed best fit vertical along an existing ground profile. So let's take a look at how this one works. It'll be very similar to the horizontal one that I showed earlier. So let's take a quick look at this particular example. So here's my existing ground profile there. And I'm going to navigate to my vertical tools now, define best fit profile. Again, you have similar options like you did for the horizontal. You just have upper envelope, lower envelope here to kind of determine the range above and below the existing ground profile. And you also have some design parameters for crest and sag curves and minimum curve length as well. So let's go in here and select that existing ground profile. Just utilizing upper envelope value of 1, lower envelope of 0. We'll just cycle through my design parameters there, and what it does is it tries to go in and create that best fit vertical between that envelope that you define. So I defined 0, I defined 1, so it's going to try and create that vertical alignment between that particular envelope from 0 to 1. Okay, and so now at this point, after it's done that, again, you can probably go through and assign some design parameters to it to kind of check your design as well. Okay, so that concludes all of the regression tools, best fit tools, whatever you want to call them, for creating geometry that I know about. If there's other ones out there inside the software hidden somewhere that I don't know about, please let me know. These are all the ones that I know about. At least inside of OpenRoads Designer. I do know inside of OpenRail Designer, the regression tools are much more robust. There's a lot of more advanced functions that you can do with these regression tools. So if you do have OpenRail Designer, I'd encourage you to take a look at those for more advanced functionality. But I think for most road applications, what we have here, what we have over in the complex geometry tab with the other best fit tools, is probably going to suit your needs for most projects. But if you do need to do something that's a little more advanced than that, then you may want to consider taking a look at OpenRail Designer. And once again, OpenRail Designer, we do have a session on what's new for OpenRail Designer on Thursday at 10 a.m. Eastern. So you can see more about the regression tools there from a rail perspective. Again, I was mainly focused and concerned about the road application and how we would use this in a road context and how you'd use it for road design. So that's kind of where I was coming with this whole presentation. But if you do rails, we got rail for you too. And so take a look at that one. That one's going to be on Thursday again, 10 a.m. Eastern. So again, thank you everybody for attending.